Hello, sir. It's video making time. Get up, sir. Viewers are waiting for your video.
Okay, Jarvis, let's start the video. Hello, everyone, and welcome to my Cyber Safeguard YouTube channel. If you like the video, like, share, and subscribe my channel, and don't forget to press the bell icon. So, in this video, we will discuss about the topic OSI model. That is very important in networking and as well as in the field of cybersecurity or ethical hacking. So, let's dive into the ocean of OSI model. The OSI, Open Systems Interconnection Model, is a conceptual framework that standardizes the functions of a telecommunication or computing system into 7 distinct layers. Each layer serves a specific purpose and interacts with adjacent layers to facilitate communication between devices over a network. Here's the type of layer as follows. 1. Physical layer. 2. Data link layer. 3. Network layer. 4. Transport layer. 5. Session layer. 6. Presentation layer. 7. Application layer. Physical layer. Think of the physical layer as the foundation of communication in a network. It's like the actual physical infrastructure that enables devices to connect and communicate. Imagine you're sending a letter through the postal service. The physical layer would be equivalent to the roads, mailboxes, and delivery trucks that physically carry your letter from one place to another. It deals with how data is transmitted over cables, wires, or wireless signals. In simpler terms, the physical layer is all about the raw, physical connection between devices, like plugging in an Ethernet cable or sending signals through the air via Wi-Fi. It's the very first step in sending or receiving any kind of data over a network. Data link layer. Think of the data link layer as the neighborhood post office. Its main job is to make sure that data sent from one device to another within the same network arrives correctly. Imagine you're sending a letter to a friend. Before you drop it in the mailbox, you put it in an envelope. The data link layer works similarly. It puts the data, your letter, into packets, envelopes, and adds addresses, like sender and receiver addresses, to them. Then, just like the post office, it makes sure that these packets are sent to the right destination. It also checks for any errors during transmission, like if the letter got torn or damaged in the mail. Once the packets arrive at the destination, the data link layer makes sure they're put back together in the right order, just like your friend would open the envelopes and read your letter. So, in simple terms, the data link layer ensures that data can be sent and received reliably between devices on the same network, just like a post office ensures that your letters reach your friends. Network layer. The network layer is the third layer in the OSI model and plays a crucial role in handling data transmission across different networks. Its main function is to determine the best route for data packets to travel from their source to their destination. This involves addressing and routing, which ensures that each packet reaches the correct device. The network layer uses logical addresses, typically known as IP addresses, to identify devices on a network. By doing so, it can manage the path selection for data packets, which may need to pass through various intermediate networks or devices before reaching their final destination. This layer is responsible for handling traffic problems like congestion and for choosing the most efficient route for data, even if there are several possible paths. In essence, the network layer acts as a network-wide postman, deciding how to get the data packets from the sender to the receiver through interconnected networks. Transport layer. The transport layer is the fourth layer of the OSI model and plays a crucial role in ensuring that data is transferred reliably and efficiently across a network between devices. This layer manages the flow of data between two endpoints, providing error checking and data flow control to ensure that messages are delivered error-free, in sequence, and without losses or duplications. It effectively acts as a manager for data transmission, deciding how much data to send, at what rate, and how to reassemble the data at the receiving end. Key protocols operating at this layer include TCP, Transmission Control Protocol, which provides reliable, ordered, and error-checked delivery of a stream of data, and UDP, User Datagram Protocol, which offers a simpler, connectionless transmission model with a minimum of protocol mechanism. By handling these critical functions, the transport layer enables user applications on different machines to communicate over a network without having to worry about the network's physical details. Presentation layer. Imagine you have a friend who speaks a different language, and you want to send them a note. To make sure your friend understands your message, you need someone to translate it into their language. The presentation layer in the computer world acts like this translator. When computers send data to each other, this layer changes the data so that the computer receiving the message can understand it. It also makes sure that pictures, videos, and other files are put into a format that the other computer can open and use properly. So, the presentation layer helps different computers to talk to each other smoothly, even if they use different ways of handling data. Session layer. All right. Imagine you're playing a game of catch with a friend, where you throw a ball back and forth until it's time to go home. In the world of computers, when they talk to each other over the internet, they also need to know when to start talking, when to keep talking, and when to stop. The session layer in the OSI model is like the rule setter in your game of catch. It helps computers start their conversation, keep it going without interruptions, and then properly end it when they're done. So, just like you and your friend need to know the rules of the game, computers need the session layer to help them communicate smoothly and know when their game of talking is over. Application layer. All right, imagine you're sending a letter to your friend. You write the letter, maybe talking about your latest adventure in Minecraft, and put it in an envelope. That envelope is like the application layer in the OSI model. It's the outermost layer, and it's what the post office workers, or in our case, the network, can see and handle. Now, let's break down what's inside the envelope. Your letter is written in a language that both you and your friend understand, maybe English. But what if your friend speaks a different language, say Spanish? You might need to translate your letter into Spanish so your friend can understand it. That translation is like what happens in the presentation layer. It makes sure the information in your letter is in a format that both you, the sender, and your friend, the receiver, can understand. Next, think about how you addressed the envelope. You wrote your friend's name and address, so the post office knows where to deliver it. This addressing is similar to what happens in the session layer. It sets up and manages the connection between you and your friend, making sure your letter gets to the right place. Then, you take your envelope to the post office and drop it off. The post office workers take care of the rest, making sure your letter gets sorted and delivered to your friend's mailbox. This sorting and delivering process is like what the transport layer does in the OSI model. It handles the movement of data packets, like your letter, between devices, making sure they reach their destination safely and in the right order. So in simple terms, the application layer is like the envelope for your letter. It's what holds all the information you want to send, like emails, videos, or games. And just like how you prepare your letter for mailing, the application layer prepares data for sending over a network, making sure it gets to where it needs to go. Thank you guys for watching the video till end, and also if you like the video, don't forget to like, share, and subscribe to Cybersafeguard YouTube channel for getting the daily videos. Okay, Jarvis, now I am sleeping. While I am sleeping, search for the next topic because my audience wants to know which topic you will choose. Keep it secret until the next video is published.